Good morning everyone. In the last video, we have discussed the preparation of the different aldehydes with the different methods, and today we are going to discuss some of the method of the preparation of ketone. We are seeing those of the reactions which are capable to form ketone only. Then the first reaction is the preparation from acyl chloride. The reaction is also known as the preparation by dialkyl cadmium. Then how will you prepare the ketone from acyl halide? Here we are trying to see. Then first of all, we will try to prepare the dialkyl cadmium. This is the CdCl2 cadmium chloride when it is reacted with the Grignard reagent. This is the RMgCl. When these of the compounds will be treated with each other, you know well that the magnesium have the greater metallic character than the cadmium. So the exchange of the halogen will take place, the exchange of the halide will take place, and as a result it will form MgCl2 along with CdR2. Now the dialkyl cadmium is prepared, and now we will treat this dialkyl cadmium with the acyl halide. So this is the acyl halide RCOCl, which is treated with cadmium chloride, that is the dialkyl cadmium. Then what? The exchange again takes place and it will form RCOR along with cadmium chloride. Then this is the reaction. In this reaction we have used the dialkyl cadmium. That dialkyl cadmium, when treated with the acyl halide, it will give the ketone. The reaction cannot be used for the preparation of the aldehyde. The preparation of aldehyde is not possible by this reaction. So this reaction is only applicable for the preparation of the ketone. Now we are going to see the next reaction, that is the preparation of ketone with the help of the Grignard reagent, directly with the Grignard reagent. How will you prepare the ketone with the help of the Grignard reagent? We can prepare the ketone with the help of the Grignard reagent by treating it with the nitrite. So here is the nitrite from Grignard reagent, and this is the RC triple bond N. When it will be the Grignard reagent which will be treated with it, this is the R-MgX. What happens? The bond in between the alkyl and magnesium will break, and that will approach on the system. So it will be RC double bond N MgX, because nitrogen is an electronegative element, so it will approach to the magnesium, and the alkyl, which is respectively electropositive with respect to that of the nitrogen, so that will approach the next alkyl group. Now the hydrolysis will take place, and what will be the result of the hydrolysis? The result of the hydrolysis will be the ketone RCOR along with MgOH, that is the magnesium hydroxyl halide, and ammonia. So in this way we can also prepare the ketone with the help of the Grignard reagent. So Grignard reagent is also responsible to prepare the ketone. So these were the two different reactions where we were capable to prepare the ketone. Now we are going to see another reaction. That is called Friedel-Crafts acylation. With the help of the Friedel-Crafts acylation, we are trying to prepare ketone. It is a well-known reaction to all of you. The reaction you have already studied in the 11th standard with the name of the electrophilic substitution reaction in the case of the benzene ring. And there you have said that when a benzene ring is treated with acyl halide in presence of anhydrous AlCl3, it will form ketone, it will form acetophenone. So we are going to see the reaction. See here, this is the Friedel-Crafts acylation reaction. The first reactant is the benzene ring. When benzene ring is treated with the ClCoCl3, that is the acyl halide, then on the treatment with acyl halide in presence of AlCl3 anhydrous, this AlCl3 act as an electrophile generator, and this must be the anhydrous, because only in the anhydrous condition that can act as a electrophile generator, only in the anhydrous condition it can act like a Lewis acid. So in the presence of AlCl3 anhydrous, it will form benzene CoCl3. You can call it phenylethanone or the acetophenone along with the HCl. Then this is the preparation of the ketone with the different reactions. We have seen some of the reactions by which you can prepare ketone only. Now we are going to discuss the physical property of the system. What are the physical property of aldehyde and ketone? So we are going to discuss the physical property, and in the physical property we generally discuss only these of the 4 points: color, odor, boiling point and melting point, and last one is the solubility. Then we are starting with the color. What is the color of the aldehyde and ketones? Generally, when there is no chance of the excitation of electron in any atom, that atom is not responsible for the color representation. Due to the absence of D subshell, the excitations are not possible. So these are the compounds, that is the aldehyde and ketones, are generally colorless. They don't have any color. So when we talk about the color, they are colorless. We have seen acetone in our daily life, that is the colorless. And if any of these of the materials you find the color, that is artificially colored, that means the extra color is added in these of the substances. When you will see the next one, that is the smell, odor, they also have a specific odor, you can call it ketonic smell. And what's about the boiling and melting point? Surely higher than the other species, not as higher as that of the carboxylic acid and alcohol, but surely higher than other species like the hydrocarbon, haloalkanes, etc. So they have high boiling and melting point. And finally, the solubility. What's about the solubility? Whether it will be soluble or not? Surely it will be soluble, because it is also capable to generate the hydrogen bonding. So it is soluble with water. So these are the physical properties of the aldehydes and ketones, that is the carbonyl system. In the next video, we will discuss about the chemical properties of the system. We will discuss about the nucleophilic addition reaction and some of the other reactions. Till then, have a nice day. Bye.